Okay, this is my walkthrough of the basic identities quiz. Remember, I'm not collecting this one this week. I do want you to give it an honest try without using any reference material, or in this case, without copying from the video. But I did want to show you my walkthrough and explain my thoughts as I complete the quiz. First off, we have the collection of basic identities that was given to us last week, and we use these so frequently moving forward that it's a real good idea to have these memorized. Now, I know we haven't used them much yet, but we will starting very soon. So definitely make sure that you memorize these if you haven't already. The first two are really just definitions. Tangent of theta is sine divided by cosine, or y divided by x from our unit circle days, and cotangent is the opposite of that, or the reciprocal of that, I should say. Cosine divided by sine. For reciprocal identities, that just reminds me that we're talking about a flipped fraction, and the flipped fraction of cosecant is sine. The flip of secant, or reciprocal of secant, is cosine. And the reciprocal of cotangent is tangent. So in this case, I'm not looking for cosine over sine as an answer. In the reciprocal identity groups, I want 1 over tangent. As far as our Pythagorean identities go, the most popular Pythagorean identity is this first one here. Sine squared plus cosine squared equals 1. From it, we can derive all of the other forms of the Pythagorean identity. In the second copy, tangent squared plus 1 is equal to secant squared, and cotangent squared plus 1 is equal to cosecant squared. Now, I remember these because tangent and secant, well, actually, let me start with this one here. I remember this because cotangent and cosecant, they both have the co phrase in front of them. So if I see cotangent, then I need cosecant. So therefore, if I see tangent squared, I don't need the cosecant component, so I'm just using secant there. That's how I keep those two memorized in my head. Now, as far as our even-odd identities, as long as we've written the trig functions in traditional order, sine, cosine, tangent, then cosecant, secant, cotangent, we should recognize that these outside corners, all 4 of these, are odd functions, and it's only the interior 2 that are even. And so what that means is that sine evaluated at negative theta would simply be sine of theta, but the opposite of it. Same thing with cosecant. Since it's the reciprocal of sine, it behaves just the same way. Cosecant of theta, cosecant of negative theta is cosecant of theta, but the opposite. So with tangent and cotangent, there we go. And because these middle two are even functions, then if you input a negative angle measure, that would be the exact same as inputting the positive form of that angle measure due to the even nature of the function. So in the past, I've given just this block anyway, as a speed quiz. And what I see a lot of students do is they just copy all of the trig functions with positive angle measures down here, and then they just come through and write negative signs in front of the rest. And for a quiz, that's a good technique. That's a good approach. But it is still important to recognize what these actually mean. So if you're still having trouble understanding what it means when we're talking about these even and odd identities, please send me a message and I'll find some time to chat with you and hopefully clarify this. Now on the quiz, I decided to write this sum and difference identity group a little bit differently. We haven't seen, at least formally, we haven't seen this condensed form of the sum and difference identities. And so what I was trying to do with this layout was remind you that we've got the sum identity and the difference identity for cosine, but their layout is so similar that we could condense this into a single copy. Let me show both copies here for just a moment, and then I'll remind you of what I'm looking for when we condense this down into one. For me, remembering one formula is easier, so that's the reason why I've written it this way. But as far as our sum identity for cosine, we have to remember that it's, and you don't have to copy this down this way because I'm going to erase it in just a second. But I always remember cosines as cosine, cosine, sine, sine, and we use alpha, beta, alpha, beta. And what's interesting is that the sum identity for cosine requires the subtraction of these two. Now for the difference of cosine, it again is built with cosine, cosine, sine, sine, alpha, beta, alpha, beta, but this one down here requires the plus symbol. Now, since both of these require cosine alpha, cosine beta, sine alpha, sine beta, the only difference being the plus minus sign in between, well, what I usually do is I just condense them into one. And so that's what the quiz here is really implying. Well, we can write both of these. We can write both of these identities, the sum and the difference together, because they both rely on the same components. The only difference is that we've got a plus and minus sign in between. However, I'm going to be very specific and careful here. I want the minus sign on top and the plus sign on the bottom when we join these two, because it's the sum identity that requires the subtraction sign in between, and it's the difference identity that requires the addition sign in between. And since sum was written on the top over here, then difference needs to be written on top over here, and vice versa. With the minus sign here, we've got to have the plus sign there. In a similar fashion, we can complete the sum and differences for sine. On my copy, there was a typo here, so I had to fix that. I think I've corrected that for your handout. But as far as the sine sum and difference identities go, I remember it this way. I remember this as sine, cosine, sine, cosine. And in the first grouping, it's alpha, beta, but I don't want to use alpha and beta in the same order on the second one because I already used sine of alpha and cosine of beta. So I've got to switch my angles here, sine beta, cosine alpha. The addition and subtraction signs are in the same order. So the sum identity requires the sum of these two groups. The difference identity requires the difference of these two groups. And I think this would be a fine answer. Now, when I write this, I retain the order of the trig functions. I always write sine, cosine, then cosine. I've seen some textbooks and some students in the past prefer to keep the angle measures in order. So they'll write sine, cosine, and then cosine, sine, and retain the alpha, beta order. And I'll accept that too because they do mean the same thing. Sine of beta times cosine of alpha, those two can be swapped due to the commutativity of multiplication. As far as tangent goes, this is the one that's usually the most difficult for students to memorize. But once again, you get the context of the problem. It tends to make a little bit more sense. But this one does contain a big fraction, and in the numerator we have tangent and tangent. Those two are going to be added or subtracted with one another. And in the denominator, recall that we've got 1 plus or minus tangent times another tangent. And fortunately, the order of the angles are pretty easy to remember. They just go in the alphabetical order. Or I should say the order in which the angles were presented, alpha, then beta. So when we're talking about the sum identity, the signs look like this. It matches in the top, but it differs in the bottom. So in the numerator, we need the plus sign in between these two trig functions, and in the denominator, we need the subtraction sign in between those two expressions. When we're talking about the difference identity, though, it's just the opposite. Well, I should say you know what I mean. We're going to use a minus sign in the top here. So we would have tangent alpha minus tangent beta. And in the denominator, we would have 1 plus tangent alpha tangent beta. So when we're looking at the condensed form of both the sum and difference identity, this is what I'm looking for as an end result. Tangent of alpha plus or minus tangent beta, but in the denominator, 1 minus plus tangent alpha times tangent beta. So that front page, or the first page on your electronic document, these are the ones that I absolutely would recommend that you memorize. They pay off in future assignments greatly because the less you have to reference old content or reference material, the quicker and more efficient you're going to be in doing your work in this class. We did learn about the double angle and half angle identities, so I'd like to see if you've got those memorized. But of course, if you don't have them memorized, you could derive them again with this notion here. Since we just had the sum identities established and we've got those already memorized, we could very easily reestablish them here. I'll show you what that looks like for this first or maybe second example. For sine of 2 theta, that would be the same as sine of 1 theta plus another theta. And based on our sum identity for sine, well, I need sine cosine plus cosine sine. So this would be sine alpha cosine alpha, sine cosine plus cosine sine. And I'm using, I think I said alpha, I meant to say theta. I'm using theta each of these times because, well, theta was the first angle and theta was the second angle provided to us in this problem. So this does follow precisely the format of the additive identity for sine, so we're in good shape there. But sine theta times cosine theta, well, that's sine theta, cosine theta. We could reverse these two to match so that they really do appear to be like terms. Sine theta times cosine theta, and our end result is 2 sine theta times cosine theta. And indeed, that is the double angle identity for sine. In a similar sense with cosine, we know that cosine of 2 theta is the same as cosine theta plus theta. 1 theta plus another theta is 2 theta. And using our using our additive identity, we should recall that this is cosine, cosine, sine, sine, with a subtraction in between. With the addition sign here, we need the subtraction sign here. First angle measure was theta, second angle measure was theta, first angle measure was theta, second angle measure was theta. So if we simplify this, cosine times cosine is cosine squared, and sine times sine is sine squared. And this is the first form of the double angle identity. If we replace cosine squared, or sine squared for that matter, with the equivalent Pythagorean identity, this format here, we would then see the following 2. And again, this is where it pays off having this memorized. And instead of having to reestablish all of this, the more you have memorized, the quicker you can work through this work as well as others in the future. So the other copies of the double angle identity look something like this: 1 minus 2 sine squared and 2 cosine squared minus 1. As far as the double angle identity for tangent goes, well, if the numerator had tangent plus tangent and both angle measures are the same, then in the numerator of this expression we'd have 2 tangent, and then in the denominator, since this is derived by the sum identity, we would take 1 minus tangent times tangent, and in this case tangent squared, because the two angles are the same. The half angle identities are a bit more difficult to derive, so definitely memorizing these would help. And there's just a nice pattern to them once you have them memorized, and that pattern becomes a bit more obvious when you're not deriving it every time. But with sine, we have the positive or negative square root of 1 minus cosine over 2. For cosine, we have almost the same thing, except we're going to call this 1 plus cosine divided by 2. And you can see the derivation of that in a prior video. For tangent, we have positive or negative square root of, well, this is kind of neat. Sine over cosine is how we define tangent. So you might memorize it or might remember it this way. With our half angle of sine, we had 1 minus cosine. And for our half angle of cosine, we had 1 plus cosine. So if you're thinking sine over cosine, then that might help you remember this order for that identity. I know that this video is getting a bit lengthy, but without my commentary, I think I could have completed this quiz very, very quickly, and my hope is that you would be able to do the same. Please let me know if you have any questions. I'd be happy to help. Reach out to me through Schoology or through email, and we'll try to set up a meeting while we're all on home instruction. Thanks for watching.